I really gotta spend some longer time. We now have it recording. So we finished up chapter 3. We're still behind schedule, unfortunately, because of this year. So we're, as much as I know you guys would love to have a break, we can't take one. We're gonna be starting in on the next chapter, like today. Okay, so your next homework is gonna be due Monday. But honestly, I think you're gonna have a pretty easy time of what we're doing right now. So as ever, there's been another assignment that you'll find at the end of the week. I will also move it over into week 17 as week 17 begins. Sometimes for this, oops, this is in the wrong location. I try to make sure that these are in order. You'll see that we have this due classifying triangles that's due on the 14th, okay, which is 13 through 37 off. But before we get there, we need to learn about them. And a lot of these you've probably heard about before in the past, okay? A lot of this I don't think is going to be new information. All we're trying to do is classify different types of triangles. Okay, we know that not all triangles look the same. Sometimes they have sides that are all the same length. Sometimes only 2 sides are the same length. Sometimes all 3 sides are completely different. Okay, sometimes we see a relationship between angles, sometimes we don't. So rather than reviewing, we're just going to jump right into it. Previously, we measured and classified angles themselves. This time, we're going to be identifying and classifying triangles, okay, a set of 3 angles together by using their angle measures, and we're going to classify them by side measures. So we can classify these triangles using sides or angles. So we have all this new vocabulary. And backtrack just slightly. Okay, acute triangle. We've heard about acute angles before. Okay, those were ones that were less than 90. Equiangular, so I'm going to have equal angles. Obtuse triangle, well, we know that angle too, greater than 180. Right triangle, exactly 90. Equilateral, equal sides. Lateral is always like a side, okay? Isosceles and scaling. Those are the only 2 so far that don't really seem familiar. Are they familiar to you at all in your experience?
I've heard about some. I remember learning about the isosceles triangle.
Yeah.
So you've heard about them, but these seem to be a little bit more distant in our memory rather than the ones above.
Yeah.
Okay? So we need to know what those 2 are. So we are going to classify these by angles. And if we classify them by angles, if we have 3 acute angles, we have an acute triangle. Okay? If those acute angles are all equal to each other, they're congruent, we have an equiangular triangle. If one of those angles, though, is obtuse, so we'll have 1 obtuse and 2 acute, we have an obtuse triangle. And then our favorite that we like to use the most is this right triangle, because we know the relationship very easily between those sides. A squared plus b squared equals c squared. Okay? So these seem pretty easy. Classify this triangle as acute, equiangular, obtuse, or right.
Equiangular.
Equiangular.
I'm never gonna get used to saying that.
What?
I'm not gonna get used to saying that.
It feels a little awkward on our lips. Equiangular. Equiangular, it's tomato. Okay? So 3 congruent angles, it's equiangular. How about this one?
Obtuse.
How do you know that?
Because
Because it has 1 obtuse angle. Couldn't all math be like this? Yeah, kind of a nice break after what we just did with all of our multiple steps. But we have to start over at the beginning for chapter 1. So this frame for the window is made up of many triangles. It asks us to classify triangle ACD. So the triangle includes the 3 points A, C, and D. What kind of triangle is that? We're going from
Oh.
It's not
here
Oh, I'm
to
thinking.
here to here.
Yeah.
I see an acute, and an obtuse.
I was thinking ACB.
Okay.
I was thinking that it said ACB.
Yeah, ACB.
ACB is probably, well, I don't know. It's probably.
I'm not sure. I would have to measure it. I think those might be the same.
It's
but
either that or it's
ACD
acute.
ACD though itself is obtuse because it has that obtuse angle near C. Okay. How about ADE?
Right.
Yeah, right angle.
Right angle, because at D we have that right angle. So this is a right triangle. Okay, classify X, Y, Z as acute, equiangular, obtuse, or right.
Right.
Yeah, that's right.
Okay, what's the reasoning for that?
40 plus 50 equals 9.
40
Yeah.
plus 50 equals 90, so
That's
I
what I
have a
was gonna say
right
too.
triangle. Okay, angle addition postulate says we can add those two angles together, the XYW and YWZ. So this is a right triangle. Okay, what do we have here?
This is acute.
Yeah.
This is acute. Why?
Because
They're
none
not
of the
equal.
angles are
All 3 angles are acute, none of them are obtuse,
And
none of them are equal,
None of them are 90.
none of them are 90. Okay, so now we can classify triangles also, not just by their angles, but by their sides. If all 3 sides are the same length, we have an equilateral triangle. If we have 2 sides that are congruent, but not the third, that's isosceles. And if none of the sides are congruent, they're all different lengths, that is when we get the scalene triangle.
So if you have like a scaling acute sign, wait, is that not possible?
Technically, scalene and acute would both be ways to classify that same triangle, but it depends on, are we asked to classify it by sides, or are we asked to classify it by angles? It wouldn't be necessary to necessarily include both unless they asked us to include both. It's a good question, because he says, this is an acute triangle. That's true when we're classifying by angles. This is scalene if we're classifying by sides. Both are describing, it's like, Richard is a boy. Richard is wearing a black hoodie. Yeah, like they're both true. It's just whether you're describing, what you're asked to describe about the person. So it depends on what we're asked to classify for the triangle.
Well, that one makes sense because then you don't have to say Richard is a black hoodie.
Hopefully not. Okay, let's classify these triangles by sides. It says the triangle truss shown is modeled for steel construction. Classify the angles JMN. So that's JMN, JKO, and OLN.
JMN is obtuse.
JKO.
Okay, we're classifying by what?
Angle.
By sides.
Oh.
Yeah. Wait a minute.
It says
But
it
it
as
says-
I agree, it says acute, obtuse, or right. That's a poor, okay, let's follow with what they said. I was looking at
Let's just
this
do
again.
both.
We could, okay. So JMN is what?
Obtuse.
Obtuse. Could we classify it by sides?
It would,
We
Well,
don't
yeah, we
really know for sure, because they don't give us anything about the length of the sides. We don't see if anything's congruent. We'd have to make some guesses. So I think we're gonna have an easier time with this and not worrying about the sides quite yet.
Okay.
How about JKO?
No, that's
Cute.
cute.
That's cute.
That's a cute. So both of them so far, we have an obtuse and an acute. We're unsure about side links. OLN,
acute.
acute as well.
Well,
It would be
and then
equal.
KOL.
Okay, actually, JKO, we said acute. I'm not sure about that.
I thought it was right.
Oh.
I feel like that's a right angle. I think that this is a perpendicular.
Yeah, that's what I was gonna say, cause KLO is a right angle.
But they didn't give us that information.
Yeah, KLO is a right angle.
Let's see what they say. They say JMN is obtuse, JKO is right, OLN is what?
It didn't even have that as an option.
Not really, you know, should go.
Some days, you know, the book makes mistakes just like I make mistakes. The important thing is the understanding. And I think we have the understanding. I don't know why they said OLN is equal angular when that wasn't even,
Option choice.
yeah. They're mixing up their classifications by side or by angle. Okay, classify A, B, C by sides.
By size.
I'm getting,
By sides.
I'm getting an equal.
I don't know, I maybe.
Or it might be
No,
a
it's
sauce.
not.
I kinda feel like it's isosceles.
I don't feel it is equilateral.
Yeah,
Yeah, I feel like
CD looks a little shorter than.
Let's put it this way, if I were to drop a
know.
perpendicular from C to here, you would see this right angle, and you would see that this is definitely longer, I think, than both of these put together. I think that this one is isosceles.
Yeah.
Yeah.
AC and BC look the same length, AB seems shorter,
So-
okay? You also have the same thing though for ACD. It's also isosceles, because AC and CD are the same length.
Oh yeah, that's what I was thinking of. I thought
So
it was
you're gonna have
ACD.
4 different isosceles triangles here. What if I took ABD?
That's isosceles as
That'd
well.
be-
That's
No.
what I was
That'd
No.
be right.
Right.
ABD, I have a right angle
Oh,
right here.
ABD. I was thinking of AC.
Well, we talked about that just before. Okay, point Y is the midpoint of VX. And WY is 3.0 units. Okay, so they tell us this length, this length, this length, and this length. They say that this one was 3.0. What is the triangle VWY?
Scaling.
Scaling Y.
None of them are equal.
Nothing gets close to each other.
Okay, so we know the measure of VW is 4.5, YW is 3.0. What's my measure of VY?
Half of
V1.
8.4.
Half of 8.4, so that's 4.2. We have scaling.
Oh.
Yeah, they go through by several different steps to tell you what VY is. And because we compare those 3, we know that we have different lengths, it's scaling. Okay, C is the midpoint of BD. Classify ABC. Okay, triangle ABC as equilateral, isosceles, or scalene. They tell us that this is equal to this, and both of these then are 1.2. What is BC?
3.4, like half of it.
Mm-hmm.
So that's 1
Well, no, because, okay,
7.
the triangle ABC, only two sides are congruent.
Well, what they're doing is they're trying to do a calculation to work out what BC is, to find out, is that possibly congruent?
Jury.
Just that BC section. If we take the 3.4,
I know, I did like
cut it in half,
1.7.
So- is BC congruent to the other two sides?
No,
No. So therefore it is
Irrelevant.
isosceles. It is very relevant, especially if you want to pass geometry. Okay, find the measures of the sides of the isosceles triangle KLM. So this is isosceles, okay, with base KL. So two sides have to be the same length. One side is different.
I think we already know it's two sides of the same length.
You're not sure?
No, I think I know.
You think you know?
Just looking at the picture.
So step one, we have to find out what D is. We have to solve for D. Okay, they say that we're given that KM and ML are equal to each other. These are our two equal sides. This one is much longer. Okay, we can tell that because we have an obtuse angle here, and these two are acute. That helps us to determine that. So if those two are equal to another, that means that 4D minus 13 will equal 12 minus D. We substitute that in. Now do the algebra to solve for D. We add D to each side. We add 13 to each side. D equals 5. So what's a side length then for LM? 12 minus 5
Did you say five?
is,
No, 12 minus D.
12, so 12 minus 5 is 7. 4 times 5 minus 13, 7. D plus 6,
11.
11. So we have 11, 7, 7.
Wait, fuck, okay, yeah.
Whereas the substituting in what we know for D,
I just thought it was 13 because we kept getting 7. So I thought D was 7 for
no. I understand. Sometimes our brains do that, and we have to catch when we make those mistakes. That's when we have the chance to go back over
Very
our
windy
work.
outside today.
Okay, so we have 7, 7, and 11. Okay, find X and the measure of each side of an equilateral triangle if AB is 6x minus 8, BC is 7 plus x, and AC is 13 minus x. Where do I begin?
Find X.
This is where like a picture kind of helps. What kind of triangle do we have?
Equilateral.
Oh, what's an equilateral triangle?
All these sides are triangles.
All the sides are the same length. So I can take any two of these sides and have them equal each other. Okay? If I do that, look at this is 6 times x. Okay, I gotta do division. 7 plus x, 13 minus x. Oh, let me stick with AC and BC. Because all I have to do is add and
I already
subtract.
know the answer, but
Okay? So 13 minus x is equal to 7 plus x.
Alright.
Add x to this side. Add x
2x.
to that side.
Dang.
Yeah, let's do that.
Oh, that's a lot.
It
Let's-
is a lot. It's a bunch of different stuff, quite honestly.
You got a little bit of blue, you got a little bit of pink.
Yep. It's multiple different classes that we've written stuff over time. The between middle school coding, middle school engineering, a little bit of geometry over in the corner.
Middle school coding.
Yep, middle school coding. So just to make sure that people see this, although a lot of this can be done in your head, sometimes it's just better to write it down to make sure that we keep it straight. Okay? We're gonna take the easy ones, since they're all equal to each other, we're just gonna say 13 minus x is equal to 7 plus x. That looks pretty easy to do. Add an x to this side. Add an x to this side. I'm left with 13 is equal to 7 plus 2x. Take the 7 from here. We're gonna subtract 7, subtract 7. We're left with 6 is equal to 2x. X seems pretty easy to solve for. Do I have an answer?
Yep.
So what is the length of my sides?
So
They're all
plug it
10.
back in.
Plug it back in, 7 plus x?
10.
10. There we go. Aren't you glad we're back to the beginning of a chapter?
Yes.
Yeah.
This feels kind of nice before the break.
That's it.
Because honestly, that's it. And I would recommend start looking at your homework, okay? Your homework in this case, you look on Google Classroom. I'm going to
How
head
much
back
time
to
do you have
that.
in class?
About 5 minutes.
Yeah, I don't
You
have
you
my
could
book.
probably get a lot done in 5 minutes, quite honestly.
I don't
On this
quite-
one,
I don't have my book though.
you have a computer.
I mean, I don't know how to log on to the online computer. Because I only use my book.
Okay.
Okay, this is it.
Oh no, I can do this at home. This is easy.
I agree.
I told my dad the Wi-Fi was trash, but he didn't seem to care.
Hey. We understand.
Okay, so what we're looking at doing is
13 through 17 odd.
13 through 37 off.
Ooh, another one of these problems. Nice. Okay.
Dude, mine
Okay.
SpongeBob SquarePants.
Is practice here or for last day?
Here, I'm pretty sure.
Good.
SpongeBob SquarePants.
And then of course, if you're doing this on paper, keep it in your book or keep track of this so that you can just finish it up on Monday if it takes that long. 13 through 37 off.
Ooh, come on, almost there. Alright. Plug it back in. Wait, Miss Lisa?
Mm-hmm.
Cause this one is the find the where they're all like.
Uh-huh. So they're all the same.
So this is the one you could like say that Q or
It says find x and the measures of the unknown side. So yes, you have to say what QR is. You'd say QR equals RS equals QS, which equals whatever the value is when you plug the x back in. This is why I don't get my geometry done. Did you notice that? Oh!
We're just looking over
Oh!
notes. We're looking over notes.
I feel like a Wookiee.
Are we gonna get a Vex class back?
You don't have a
I
Vex-
make no promises.
There's no
for
Vex
anything
Talks
right
this year?
now. No,
No, that's why
we've done nothing Vex this year.
You said that's all from last year.
yes.
Yeah.
And the game's supposed to be fun this year too.
The new game is like mini basketball with both robots.
Yes, the new game was gonna be really fun.
No, well, it's mini basketball. It's basketball slash tic tac toe.
Yeah.
Right, that's it.
It's like basketball cross with
You like
tic tac
supposed to
toe.
stack it. There's like 3 goals on each side, and you stack them.
And if you
And you
get
can
an entire
de-score them.
row, you get bonuses.
Yeah, because I remember we watched the video right before we left.
Thank you. You're like the only one. Everyone's
Yeah.
like, "What's the game?" I'm like,
We watched the video right before. We watched the video right before we.
"Yeah, we had a test on it."
Yeah, I remember doing that.
There's people that don't.
It's 3 goals on on each side.
Obviously,
and then
like
there was
Richard.
like 4 towers or 3 towers in the middle. And then
I don't need to worry about
And
the
then
I
you
just
can,
threw you under the bus.
You can play defense the whole game or play offense. It just
Yeah, I was never in here, so.
It's okay. All 3 of them had robots last year, so you get a little bit more
I
involved.
remember Richie was upset about the middle school class, so he switched to the high school.
Oh my gosh, yes, that was so
I requested a trade. I was not able to.
That was